Good morning. Welcome back to Grade 8 Math. So today we're going to take the second step in the Pythagorean theorem. There was just too much to cover in one day. It really wasn't worth it. So today we're going to look at a couple of real life applications of it and another way to figure out something, the distance in a graph. So that way when you get to Algebra 1, it will be something that's relatively familiar to you. So again, I know I had this meme last time, latest scandal, Pythagoras caught in love triangle. Hopefully it makes a little bit more sense today, as well as the c squared between Einstein and Mr. Pythagoras. Okay, so if you remember from last time, we had talked about the formula for the Pythagorean theorem, and it was the relationship in any right triangle between the two legs and the hypotenuse. Okay, remember we said leg, leg, and hypotenuse. And it's just if you square one leg and you add it to the square of the other, you get the square of the third side, or the side opposite the right angle, which we call the hypotenuse. So last time we just did pretty little triangles. Today we're going to look at some real life applications of it. So one of it deals with actual roofs. Now we're going to use pyramids for this, which is basically semi-similar to what a roof is, but it's not quite. If you notice, this roof these all have different pitches. Now we're not figuring out what the pitches are, but how those pitches affect the amount of material that you need. Now we're not going to solve that, but that's just how this is a real life application of it. So if you notice that this has a less steep pitch than this one, but this one has the least, well, this one has the least steep pitch. And if you think about it, if I cut it down the center right here, if I go from there to there, that's basically a right triangle. Okay, go up there, boom, down to that. Go up here, boom, down from that. It's just a right triangle. And the more steep that the roof is, the longer that the roof is going to actually be. And how does that deal with what we're going to do today? Well, you're going to need to know how much material you need to buy. How long do these pieces of wood need to be? How much sheathing do you need to have, which is the wood that they put down on top of it? How much shingles are they going to need to have? Okay, so all these things go into the factoring of it. So let's come up with some. Okay, so let's look at the situation. So we're going to look at just pyramids for this. There are some roofs that do look exactly like this. So if you notice, there's a couple of different right angles in here, but what we're really focusing on is this. And if you remember last year, this is called the slant height. You did this when you're doing surface area. You also did it in 6th grade as well. So what is the slant height of the pyramid? Well, in order for us to do that, we need to know two things. We need to know the height of the pyramid, and we need to know the distance to the center of the pyramid. So they actually give those to us right here. All right. So the height is 6.4 inches, and the distance to the center is 4.8 inches. And if you notice, it's a perfect right triangle. So this right here is the hypotenuse. So remember, the square of this plus the square of this is going to give us the square of that. So let's go ahead and put those in. And you notice I just put parentheses around them. That's generally a good habit, especially if it's not an integer. It just makes it a little bit easier to see. So 6.4 squared is 40.96. And 4.8 squared is 23.04. So now we add those up, and we get that becomes 64. That equals c squared. So now we just take the square root of both sides. And c equals 8. So the length of this side is going to be 8 inches. Okay? Let's go to the next one. Now this one looks a little different. This is more if you had, people will see this particularly if it's more of a modern house, or sometimes if it is a shed. They'll put this type of roof on top. And it really just looks like this. It's just a triangular prism. All right? We're still going to be using the same type of strategy to solve. We're still going to solve it the same way, because if you notice, this is still a triangular prism. So if this side is x, this side has to be x too. So we remembered it was x squared, or a squared plus b squared equals c squared. So 9 squared plus 12 squared equals x squared. Now, why did I put x squared and not c squared? Because it gives me the variable. That's what I'm trying to find. If you notice here, I did not have a variable, so I just kept it as c. Here it actually gives me a variable. That's why I used it. So this is 81 plus 144. That's x squared 81 plus 144, so that's 225 equals x squared. Take the square root of both sides. X equals 15. Since it is yads, answer is 15 yads. Super exciting. Okay, now what we're going to do is we're going to look at a graph or an ordered pair and how far 2 points are apart. Okay, so now we're going to look at 2 ordered pairs and try to find the distance between them. So going from one point to the other is really, really difficult. You really can't do it, okay, unless you have some kind of rule or some kind of measuring device. Well, we can break any motion from one point to another into a change in y divided by the change in x. That should be very familiar to you. That's called the slope, or the slope. Now, if you look at it, when we break it down into the rise over the run, isn't that not just a right triangle? Yes, it is. So we have the difference in y's, or y2 minus y1. And this is x2 minus x1. So we're doing the same thing you did to find the slope, but instead of dividing those two, what we're going to do is we're just going to take the square of this and take the square of that. So what's y2 minus y1 here? I know it's already labeled. This is for the next slide. Okay. So what is y2? It is negative 3. What is y1? That is 5. So that's negative 3 minus 5. Okay. Well, negative 3 minus 5 equals negative 8. But Mr. Parad, we can't have negatives in this. You're right, we can't have negatives in this. In this case, the negative is just a direction. It's still a distance. It's still going 8. It's just going 8 down. The negative is going to come out in the next part, so don't worry about too much of that. Okay, so now x2 is 4 minus negative 2. So these are my x's, so x2 minus x1, just so you know what we're doing. Okay. And that gives us 6. So the distance here is now, as always, it's going to be the absolute value of this. So it's going to be a distance of 8 down, and it's a distance of 6 over. And then using Pythagorean theorem, that's going to give us this one right here. So we have 8 squared for a squared, and then 6 squared for b squared, and that's going to give us c squared, or the distance between the 2 points. I'm just going to move it up here because I ran out of room. So 8 squared is 64. 6 squared is 36. That's going to give you c squared. 36 and 64 is 100, which is c squared. So take the square root of both sides. C is 10. Okay, so technically it's 10 units because these are units. Now let's do one more. Now this one does not have the graph listed or drawn for you. You still can do it, okay? Because what it is x2 minus x1, and we square that, okay? And we add to that y2 minus y1. Because remember, this is the run. I'll just write run over it. Run. This is your rise. And that's going to equal the distance of the between the 2 points. So x2 minus x1, so we'll do 2 minus negative 3. That's going to get squared. And this one is 8 minus negative 4. We're going to square that, and that's going to equal c squared. So 2 minus negative 3 is going to be 2 plus 3, or 5 squared. 8 minus negative 4 is going to be 12. So that's 12 squared, and that's going to equal c squared. So let me just draw a line so we can come up here. 5 squared is 25. 12 squared is gross, 1 far. That equals c squared. So 25 and 144 is going to be 169 equals c squared. So you take the square root of both sides. Square root of 169 is 13. Okay. So good luck today. Reach out if you have any questions. Bye.